Hi, my name is Chris Grabowski. I'm a Senior Solutions Architect at MongoDB out of Philadelphia. And today I want to talk about a second way to migrate data from your self-managed clusters into MongoDB Atlas, our hosted database as a service offering. Previously we talked about Live Migrate, which allows you to have Atlas reach into your self-managed cluster. Obviously that requires some network configuration. So the other way to do it would be to push the data out of your self-managed cluster using a tool called mongomirror into Atlas. It still has the same benefit of keeping everything in sync until you're ready to cut over your application with zero downtime. So to do that at a high level, here's what we're going to go through today. Outside of scope is to sign up for accounts for both MongoDB Atlas as well as Google Cloud. So we're going to assume you already have those two accounts up and running. The first thing we're going to do today is deploy a self-managed replica set in Google Cloud along with a sample application. Under normal circumstances, you will already have this deployed, either for you or your customer, but this will be a good quick tutorial on how to deploy some virtual machines within Google Cloud. After that's done, those two machines will be in the same VPC in Google Cloud, so we will peer that VPC to the VPC in MongoDB Atlas. We will then configure some settings in MongoDB Atlas to allow communication, and then we will use the CLI tool called mongomirror to push the data out of the cluster into MongoDB Atlas. The last step will be to cut over that load generator sample application, and at that point we'll be up and running with MongoDB Atlas. So the first thing we're going to do is we're going to go over to the Google Cloud Platform console. That's located at console.cloud.google.com and sign in to our account. Right now we're not in a project, so the first thing we're going to do is create a project for this. So to do that, we can just click the Create New Project button. We can give it a name, in this case, mongomirror, and click Create. Okay, so our project is fully deployed. So first thing we're going to do is deploy a compute instance to install MongoDB on. The simplest way for me to do navigation is just to use a search. So up top we can search for compute and add VM instance inside compute engine. When that page comes up, we're going to create a virtual machine. In this case, we're going to call this one MongoDB, where we will install the database. I'm going to use this in US East 1. The standard series and machine type are completely fine. I prefer Ubuntu, and the instructions will be for Ubuntu as well. And we will choose Ubuntu version 18.04. We can leave pretty much everything else as is. We'll come back for this and then click Create. While that's deploying, we're going to build an identical machine, but this one's going to be called App, which will install our sample application on it. Again, same exact location, size, and operating system. Great. So now we have two machines, one which will be our database and one which will be our application server. So next up is we need to connect to our instance and install the two applications. So to do that, I'm going to use Cloud Shell built in by clicking the SSH button. We will make this full screen and zoom in so we can see exactly what's going on. Okay, so next up is actually installing the application. So to do that, we will dig in a little bit and run a couple CLI commands. Now, these are not complicated, but I do have them outlined in the description of the video, so that way you can run them on your own. The first thing we need to do is add the public key for MongoDB Enterprise Advanced. Then we will actually add the repo for MongoDB Enterprise Advanced. We will update the apt cache. And the last thing we will do is install MongoDB. In this case, I am specifying the version, and I'm going to run MongoDB version 4.0.15. So this will take a quick minute to install, and then we'll come back as soon as that's done. So MongoDB is now fully installed. What we'll have to do is edit the configuration file to modify a couple of default settings. So let's zoom in a little bit more so we can see exactly what's going on. The default configuration file is in /etc mongodb.conf. And this will work for most cases, but a couple things are need to be changed for our use case here. So the first thing is this current setting will only allow the local host to answer, so basically application needs to be installed on this machine. So we will change this to all network interfaces on this machine. The other thing is this is currently configured as a standalone instance. We're going to make it part of a replica set by using replication, and we give it a name, repl set name. In this case, we will just call it RS migration. The last thing is now, since this is available on the network, we need to add a basic username and password authentication and authorization mechanism. And to do that, we say security authorization enabled. So with that small change, we can write the configuration file and start MongoD with sudo service MongoD start. So at this point, MongoDB should be up and running. And what we can do is we can initiate the MongoDB replica set, and that's done with a command called rs.initiate. And that lets us know everything's up and running, and we are now a replica set. The next thing we need to do is add a default username and password. The reason I'm able to do this right now is because we have what's called the local host exception. So I'm allowed to create the first user, but I have to be creating that user from the actual machine MongoDB is installed on. So I'm going to create a root user to make sure I've got all privileges to do that later. And the user is added. But we wouldn't want to give the root username and password out to anyone for application purposes. So we're going to add one more user for our application. In this case, that user is going to be called app user, and the password will be app user 123. The roles for that instead of root will be read write any database. So we will add that last user, and just to make sure everything's up and running, we can run rs.config, and that will tell us the status of the replica set, and everything looks good. Perfect. So now MongoDB is up and running, so the next thing we need to do is configure our application server. So to do that, let's go back to Cloud Shell for the machine called app. In this case, we'll SSH into this machine. Okay, so Cloud Shell is up. Let's make this full screen as well and zoom way in. So again, the couple commands we need to run here are not too complicated. They are basically going to be, let's update apt again to update the cache. Our sample application is written in Java, so we will install Java. And the last thing we're going to do is actually use our sample application. Now the sample application we're going to use is something called the POC driver. It's something people at MongoDB use relatively often, written by John Page. It's on his GitHub. So it's a simple .jar application that will allow us to do sample reads and writes, allow us to tweak the document schema, change the read-write patterns, etc. So it's very useful to put load on a system and allow us to basically get up and running. You could use any sample application, but because this is pre-built and we've got experience with it, this is what we'll use. So it's already pre-built. We can just do wget to download the jar file, and now it's up and running. So to run this, what we're going to do is we are going to run java-jar, the name of the file, in this case POC driver, -c is the connection string for the server. And MongoDB connection strings typically look like this: MongoDB : the username, app user. Remember, we created this a minute ago. The password, app user 123, at the host name. And the host name we can get from here. So we'll use this internal IP address right here. We will copy that so I don't make a mistake. Everything after this is basically settings which are outside of scope. They just run against the driver, the POC applications, to do things like change how many threads we are running, the duration of our workload, the shape of our workload, etc. So we'll use these settings and they will be in the documentation below. So with this up and running, we can see it successfully connected and it's inserting and manipulating data. If we go back to our server, which is running MongoDB, which is right here, I can zoom in again. And here I can run the command called dbstats, which will basically allow us to see the statistics of the database. In this case, it's the POC-DB database, and the password was root123. So we can see here this database is created, how many collections it has, how many objects, the average size in kilobytes. So we know that the sample application is successfully writing to the database. So now we have a self-managed MongoDB cluster up and running with an application writing to it. So the next big thing we're going to do is now peer this VPC to MongoDB Atlas, which is our database as a service offering. That will allow us to then have a private connection between these servers and MongoDB Atlas, and then from there push the data from this server right here to the cloud and basically cut over with no downtime. So to do that, I'm going to go back to my browser here, and this time instead of working in the Google Cloud Console, I'm going to go to the MongoDB Atlas console. So that's at cloud.mongodb.com. So I'm already logged in. The first thing I need to do is restrict data to this project, even though I don't have a cluster in here yet, to basically say I'm only allowed to connect application servers which are in a peered VPC, not over the public internet. So to do that, we're going to go to the settings on the left, and in here, if I scroll down, there is a setting, connect via peering only. So I'll make sure I turn that on. Okay, so after that's done, we can go into network access here and actually initiate the peering process. So to do that, we click the network access button, peering, and then create a new peering connection. In this case, we're going to use Google Cloud. And now here's where we need to start filling some things out. So all of these things can be gotten from the settings within Google Cloud Console. So the first thing we need to do is get the project ID. So if I come back here, if I click on the projects, I can get my project ID. So that's right here. Copy that. Here. The VPC name. So if we don't know how to do that, there is the instructions here, which we can click. But I know mine is called default. And last thing here is the size of the Atlas CIDR block. This should be fine for our purposes. So after that, we can click the Initiate Peering button, and it's going to be in the peering state. To actually accept this peer, we will have to wait for the project ID and the Atlas VPC name to come up, and then we will copy paste that into the Google console. So we'll wait for this peering to establish, and then come back and cut that over. At this point, we have the project ID and the VPC name. So this is what we'll need to give Google to accept this peering request. So to do that, we'll leave this tab open because we're going to need to copy and paste this. And then next thing we do is go back to Google Google Cloud Platform, sorry. And in this case, we will search for this time for VPC Peering. Within here, we can create a connection. So within here, we can create a connection. The name, it's not so important, but we will call this Atlas. The VPC we're going to connect to is default, which again is what I typed in earlier. This is in another project, and the project ID and VPC network name are what they give us here. So here's the project ID. We can copy that. And the VPC name. And then click Create. So this will take a couple minutes to run. Once it's done, it should come up green on both sides, letting us know everything is okay. So we'll cut back when this is complete. Okay, and now our status is active, letting us know everything is up and running. So now we have MongoDB Atlas peered directly to our Google Cloud platform. So what we need to do now is basically, even though it's peered, MongoDB Atlas is still going to prevent any communication coming in or out. So what we need to do is whitelist the IP addresses of our servers in here. So we're going to start configuring MongoDB Atlas at this point. So to do that, I can click on VPC Networks up here. So once on this page, I can look at all of the IP addressing here. I know all of my stuff is in US East 1, so I can search for that here, and I can copy paste this into the whitelist I just mentioned. I could also do something a bit more broad and say 10.0.0.0/8, or there's also a default which will cover all of Google's default addressing. But in this case, I'll be a bit more restrictive and say just the region I care about. So again, I'll copy paste that. After that's done, I will go back to the MongoDB Atlas portal. And from this portal, I can go to network access, and I have to add my IP addressing. So here I can say this address I just copied, this is Google Cloud VPC, and click confirm. So this will deploy the whitelist to allow all my 2 servers in Google Cloud to be able to talk to MongoDB Atlas. While my network is being configured, I still have to create usernames and passwords to allow my application to be able to talk to this cluster. So the next thing I can do is go to database access. I will create a new user. In this case, I can go with pretty much any of these built-in rules. I'm going to go with Atlas admin, and I'm going to create the username admin, and the password is going to be admin123. After that, I click the add user button, and that will create this user for this cluster. So now that I have a user, I have my VPC peered, and I have my IP whitelist configured, I can go deploy my actual MongoDB cluster. So to do that, I go to clusters, build a cluster, and for simplicity's sake, we'll just stick with a single region cluster at this point. After that's done, I will deploy in Google Cloud. I'm going to choose that same region as before just to keep the network latency at a minimum. But of course, we could put these in different regions or multi-region. We'll scroll down. We'll stick with an M30. That's perfectly fine for our needs here. We'll stick with these versions. We can turn off backup. We don't really need that for this demonstration. And the last thing we need to do is give our cluster a name. We'll call this mongomirror. After that, we click the Create button, and this will go deploy the cluster, which will take a minute or 2. It looks like our cluster is now fully deployed. So at this point, we're ready to do our actual migration. So to do that, it's going to be relatively straightforward. So what we'll do is we will go back to our cluster with MongoDB already installed. We have right here. We're going to install a utility called mongomirror. Now, the actual documentation for that's available at docs.atlas.mongodb.com. You can search for mongomirror. So I'm just going to give a high-level overview, which basically we're going to run this command, point to the local host, and then set the destination as the Atlas cluster we just deployed. After that, it will actually stream the data, push the data from localhost to MongoDB Atlas, and keep it in synchronization until we're ready to cut over. So once again, if we go back to this cluster, we can download the actual utility. We can extract that. Okay. Okay, and here's our utility. So after this, we can run our mongomirror command. And this will take in the host. That's going to be the name of the replica set, rs migration. Remember, we made that earlier today, /localhost. And the port MongoDB runs on is 27017. After that, we need the username and password for the system. And remember, we made username is root and password is root123. We're going to need the destination username and password, destination username. And remember, we made that the admin, and the password for that was admin123. And the last thing we need is the actual path to that cluster. So destination. And to get that, we can go back into here. We can click the connect button. we can connect the command line tools because we're going to need this full path right here. So I can copy paste this as is back into my tool here. At that point, I can now go back to my cluster. I can look into the metrics, and I should be able to see documents being inserted in real time. So this is going to be a little bit of a historical view for not only the MongoDB metrics here, but also host level statistics. So if I want to dig into any of this, both for the host, the hardware metrics, and the MongoDB metrics, I can do that. I can also look in real time. So there we go. We can see POCDB is being loaded up. It's not taking a whole lot of traffic, but it is streaming over the internet as things change. So the last thing we need to do at this point is, because everything's working, is actually cut over the application. So cut over the load generator. So to do that, I can go back to MongoDB, click clusters, click connect. In this case, we're going to connect our application this time. It's written in Java, and I can copy this connection string. So if I go back to my application server here, and from here I can basically rerun that Java command one more time. And to do that, we will run java-jar POC driver. We're going to do -c for the connection string. This time it's going to be what I just copied to my clipboard. Of course, that's not going to give us the password because that would be insecure. So I want to make sure I go back and put in my password, admin123. Again, in the real world, we'd probably create a user just for this application instead of using an administrative user, but this will work for now. After that, what we'll do is we will pass in a couple more CLI flags. Again, that's kind of outside of scope for this, but what that's going to do is basically make it a single threaded application. We're going to run this for another 60 seconds and then manipulate the shape of the data. So as I run this at this point, this will now start talking directly to MongoDB Atlas, meaning I've now fully rolled over my application. If I go back to here, which is our mirror, I can cut this with Control-C, as we no longer need to do that. We've already cut over our application, and now all of our data is in MongoDB Atlas, and we basically had no application downtime. All we had to do was cut over our application by changing the connection string to the one provided here in MongoDB Atlas. And then from then on, we could have done that as a rolling upgrade too, which means there would have been no downtime. And now that that link is cut, I can kind of discard my old database, and now I'm running fully in a database as a service offering in MongoDB Atlas. So kind of a high level one more time, if we go over this, right? What we did was we had accounts for both cloud.mongodb.com as well as Google Cloud Platform at console.cloud.google.com. So we logged into those. We deployed a self-managed database of MongoDB inside Google Cloud, as well as a sample application. Now, under normal circumstances, again, those would already be deployed and self-managed. However, just to kind of overview how to deploy things in Google Cloud, we deployed those two servers. After that was done, we peered our VPC to allow Atlas and the two application servers in Google Cloud to communicate to each other over private addressing rather than the internet. After that, we deployed a cluster in MongoDB Atlas, as well as configured some IP whitelisting, some usernames and passwords, etc. Once everything was up and running, we used mongomirror to push all of the data out of the Google Cloud instances, the self-managed MongoDB instances, into MongoDB Atlas, database as a service. And then once everything was fully synchronized, we cut over the load generator application, our sample application, meaning now we are pointed directly at MongoDB Atlas instead of our self-managed instance. So again, I hope that was helpful to see how to migrate a self-managed instance of MongoDB in Google Cloud to MongoDB Atlas using the utility called mongomirror over a peered VPC connection. So this is a very secure way to migrate that data and ensure that your data is in place and pointing to MongoDB Atlas instead of your self-managed system. And again, we can cut over the application with no downtime. So if you have any additional questions, feel free to go to cloud.mongodb.com, sign up for an account, read our documentation, as well as see the steps below in the description to try this on your own. Again, my name is Chris Grabowski. I'm a Senior Solutions Architect at MongoDB, and I hope you found this video informational. Thanks.